This short video is going to show you how the molar mass is used as a conversion factor. Molar mass is used typically to convert between the mass of a substance and an amount in moles, and I will show you how that's done in a second. Now, it's important that you remember the unit for molar mass, grams per mole, because if you do, you have a ready-built equation that you can use and manipulate, and this will help you determine or use the correct calculation when you're going from a mass to a number of moles or from a number of moles to a mass. So again, molar mass, the units, as I've already pointed out, are grams per mole. And so as symbols, here we go. There's the symbol for molar mass, capital M. The symbol for mass is lowercase m, and the symbol for number of moles is lowercase n. So grams per mole means m divided by n. So there's your ready-built equation. So there are two main calculations that you want to be able to master involving molar mass. So there's our equation still, molar mass equals mass divided by number of moles. So if we want to find the number of moles, n, number of moles n is going to be equal to mass divided by molar mass. That's capital X, or capital M of X, so the substance. And so this, you have to be given the mass of the substance, substance X. And so that's the first calculation. The second calculation is trying to determine mass. So in terms of our equation up here, again, mass would equal the number of moles of X times molar mass of X. And so in this case, we have to be given N of X, the number of moles of the substance. So those are the two little equations you need to be able to use. And again, as long as you have that one, which is based on the unit, remember the unit for molar mass, grams per mole. As long as you have that at your disposal, you can always do the manipulations to come up with the correct equation. So let's try a few. So how many moles of aluminum chloride are there in a sample with a mass of 25 grams? And here's the molar mass. So I've given you the molar mass of aluminum chloride, 133.34 grams per mole. And so we just plug it into the equation. So mass, 25.0 grams, divided by molar mass, 133.34 grams per mole. So grams divide out, and you're left with 1 on mole, which is the same as mole, and we get 0.187 moles of aluminum chloride. Now, there's another way you can do that, and that's using M as a conversion factor, like we've seen before. We just multiply. When we did dimensional analysis, we just multiplied everything. So we again, what are we looking for? We're looking for N, number of moles, equals, what are we given? Well, we're given a mass, and we're going to multiply by a conversion factor, and that conversion factor happens to be the molar mass. And so M is 25.0 grams, and we want to multiply by a conversion factor that gets rid of grams. So what are we going to put down here? Well, 133.34 grams per mole means the grams part would go on the bottom, and what's on top? Per mole, that's 1 mole. And if you notice, the units cancel out, grams are gone, and we're left with mole on top, which is good. And the math is the same, 25 divided by 133.34, so it's going to be the same, 0.87 moles. And notice we have 3 significant digits because of our given mass, 25.0 grams, so 3 sig figs. Don't forget about watching sig figs. Let's do one more example. So it's determined that there are 22.2 moles of hydrogen gas in an air balloon. What is the mass of the gas in that balloon? So again, we're looking for mass. So mass equals number of moles times molar mass. Number of moles is 22.2 moles of hydrogen times, well, the molar mass of hydrogen is 2.02 grams per mole. And so we multiply by 2.02 grams per mole. Notice moles divide out, and we're left with 44.8 grams. So if we had 22.2 moles of hydrogen, it would have a mass of 44.8 grams. And again, 3 significant digits because of my 22.2 moles. So that's how you use molar mass as a conversion factor.